Welcome to the Waddyado Podcast, where I sit down and speak with professionals having honest conversations about their careers, how they got into them, and advice for those looking to follow a similar path. But most of all, telling you, the listeners, what it's really like to do that job. In this episode, we speak with computer science lecturer at Bournemouth University, Ben Gorman. Ben shares his insights into the impact of AI in software development careers, which career paths you can move into with a computer science related degree, how to choose the right course and university to go to, and also the salaries you can go on to earn. But we also cover how going to university isn't the only pathway into software development, and how learning online via digital boot camps can also be a great route for those looking to join the industry, perhaps later in their career. I hope you enjoy. Well, Ben, welcome to the Waddyado Podcast. It's an absolute pleasure to have you here today.
Thank you very much. Thanks for having me.
No problemo. Well, just for a little bit of context, Ben and I actually kind of go a little bit way back. Ben and I met traveling, what was it, 12 years ago, I would say? Something like that.
Don't say like that. That's terrible. But yeah, no, I think it was 2012, I think, must have been.
So basically, Ben and I decided post-graduating from university that we would go and spread our wings and go and live in Australia for a year. And we actually met on the flight out with a group of people and had a wonderful experience. And then we actually ended up working together as well down in Lawn in Victoria. So yeah, Ben and I go way back. So thank you so much for taking the time out of your day today to...
No worries. I helped you get that job as well, if I remember correctly.
Definitely did. Yeah, you definitely put in a good word for me. So I'm eternally grateful. So this is you repaying the favour. Okay, brilliant. Well, just to add a little bit of context for everyone listening. So Ben is a senior lecturer at Bournemouth University in computer science and covers 8 courses across different types of, courses within the university. So he pretty much knows a lot about this type of thing, I like to say. Would you agree, Ben?
I try, okay. Yeah. Additionally, I'm also what we call like a program leader for 2 master's courses. So that's digital health and Internet of Things. So I kind of like, I'm the manager of those courses in essentially way. So yeah, additional as well.
So Ben, how would you describe what you do for a living to someone who isn't in your field or industry, or who doesn't necessarily understand what all those programs mean or what computer science really is?
Oh, interesting. So I say that computer science is how to scientifically understand how people interact with technology and how to develop better technology within computing, essentially. So if I was to say that's what computer science research is, right? When we're talking about education of computer science, it's teaching people how to work in any aspect of computing in terms of, networking, websites, mobile applications, back-end software, enterprise software. So essentially how we make the world work at the moment is really computer science. That's what I would say, essentially.
Fabulous. That's a good overview, I would say. And so what were the first things that actually influenced you to go into this wonderful path of academia, but also, within specifically computer science related fields?
Yeah, so my dad is, or was at least, an electronic engineer at Motorola. So he actually developed or worked on developing like semiconductor chips. So I was kind of always influenced in technology in general. And I think he influenced a lot of those kind of early decisions. So I was always quite technical minded. I had a lot of like robotic toys, like a lot of Lego stuff. And I think that ability to kind of create solutions is really what led me down computing. Interestingly, I didn't get to study computing in school at all because my school didn't offer it as a course at high school at all, not even in like A-level or whatever you would call it in England. In Scotland, it's called different things. So I think because I didn't get it in school, I ended up doing a lot of it at home. So I got to actually explore the bits that interested me a bit more. So I think that really spurred my interest in it as well.
Yeah, well, I think it certainly helped that your dad was around to give you and I guess teach you the ropes and the basics and the understanding for it.
Yeah, pretty much. Yeah. I mean, he didn't actually do that much computing. I kind of thought that was not the next thing, but he was more low level chips that kind of go into cars and stuff. So I was going to go either electronic engineering or computing. And I kind of thought, actually, career-wise, it makes sense to go into computing because it's going to be a bigger field than electronics is, which kind of turned out to be true, I guess.
Awesome. So you obviously, a lot of people obviously decide to then, once they go to university, go out into industry, but instead you decided to stay in academia. So what were the motivators behind that, do you think?
Yeah, so actually, if we go back to like why I went traveling as well, when I did my degree show and we had to demonstrate our solutions to the academics and also a couple of industry people, I actually got a job offer, like an informal job offer from Amazon to go and work on their web services, and the kind of other main people who had come in over those months before we graduated to talk to us were companies like Amazon, Thales, who does a lot of like missile defense stuff, and then just kind of a lot of local app development companies. So the options were go and develop some apps, which are not often used very well and don't make a lot of impact. Go and develop missiles, or go and do like banking and stuff. And I just didn't think that those were the best choices for me to contribute to like society and the world in general. So I deferred the decision and went traveling for a year instead. And then when I came back, I went back into my department that I'd made really good connections with during my degree. And I kind of asked, oh, is there any funding to do any kind of master's courses or anything like that? Because I actually thought that biotechnology was going to be the next thing. So kind of fusing computing and like medicine together, which turned out to be true back then. But I was told, no, there's no more opportunities for you. You've kind of wasted your time by going traveling, etc., etc. So I kind of left a bit disheartened. But then a couple of months later, somebody else within the department who was a bit more nicer, clearly, said, oh, there's this academic who's moved over from Canada and he's got funding for a PhD student. Would you be interested in having a chat with him? And I said, yeah, why not? Like, I can do that. So I went and had a chat. And then after half an hour discussion, it was a handshake and I was going to be doing a PhD.
Wonderful.
So yeah, and then after that, I did some teaching during my PhD. And then, yeah, I decided even after then, because I could have went into industry, that academia made the most sense for me.
Awesome. Well, that makes a lot of sense, I think. And also, if you can get it funded, happy days, right? That's a winner. Brilliant. So I'd like to dive into a little bit more around, I guess, computer science and dispel some myths, but then also talk about the different career paths that actually we can shine a light on, because ultimately I think a lot of people might think that you just do computer science and then you immediately would just go into becoming a software engineer. But actually, there are other options, which you can obviously tell us about shortly. So yeah, talk us through some typical career paths that people go into post-graduating.
So I think the most traditional one that a computer science graduate would go into, and when we say computer science graduate, we're not just meaning with that specific degree title. So computer science kind of covers everything from, a degree in software engineering, data analytics, cybersecurity, even things like a degree in user experience would really be still computer science. So essentially anything that uses computing in general. And most people would still say that the traditional role would be to actually be going and writing code as a software developer. So actually writing the actual, language that gets translated into what computers do, right? So that's obviously the most apparent to a lot of people, but that's not often the roles that most people go into. And a lot of times it's around, translating what somebody has a vision for a piece of software or a need for a piece of software. So that could be a business or a user or a client, and then turning that into code. But there's a lot of messy stuff that needs to happen between an idea and actual code getting written. And a lot of different roles sit between that. So information architect would make sense. So that's what kind of about translating the user need into what the software developer needs to implement.
And also can be known
can be a really common
solution architect as well.
Yeah. And yeah, I think a lot of sales roles, because it's useful to understand how or what can be done in terms of computing to know what's translatable into a product, right? So for instance, somebody who spends a lot of time talking to clients about their needs can still be a really traditional pathway for a computer science graduate to go into.
Absolutely. I would say also, just to add to that I do a lot of sales engineering recruitment. I run a tech sales and marketing recruitment agency, Autos Talent. And within that, we work with a lot of clients globally who need that extra technical understanding from on the sales side of things, especially if it's a very technical product, especially, related to like AI or cybersecurity things, like as you just mentioned there, that they often get involved and work with account executives to provide that technical understanding when they're working with clients, and then ensuring that they can deliver on that as well, from working with the engineering teams to ensure that actually that can be delivered from a technical standpoint. So I think even if I think a lot of people think and make assumptions that you have as a computer science graduate, you might be a little bit more introverted, but actually it's not necessarily the case, and you can use your personal skills in order to transfer them into more of a customer facing role as well.
Yeah, and if you actually look at, for instance, Bournemouth's degrees, there's still a lot of programming units, we would say, within the programs, but there's a lot of other things that go around those. So they don't really stand on their own. And even when they do have to submit their code, essentially, they're never really just marked purely on that. It's more about explaining and justifying why they've made those decisions. Because as you said, like one big area of recruitment for computer science graduates is going into consultancy firms, who then go into companies and try and do like digital transformations and things such as that. And again, it's the ability to explain, okay, we could use this piece of software and it would cost you this much. Here's why this is the best choice. And it's never really just a financial decision. Something could cost more to implement, and it's better for long-term, security implications or maintainability, reliability. So understanding those different kind of considerations of any computing system is something that any graduate from computer science will be able to do. And it's not often an easy thing for somebody who just has an understanding of how to program a code at a very low level, which is actually, a lot of people ask, why should I go to university and study computing versus doing like an online code course? And I think on the online code courses, those bits are always not really well put in there. They're not really part of it. So like project management of a computing project, it's never going to be really taught on these online code camps, but it's very, very vital, because the amount of code that even a software developer will do in a company, like lines of code, is quite small, right? It's more about understanding what somebody else has implemented.
Awesome. So you obviously mentioned solution and information architect, and also sales, I guess, solution engineering or sales engineering type positions. Is there any other routes that you see people going to?
So like testing and quality assurance. So, if we think about recent cases in the news, for instance, companies like Boeing and obviously the post office scandal, right? Those two examples, if you connect the dots back, the code functioned as it was designed, essentially, but the way it functioned was wrong. And the place of quality assurance is making sure that those things don't happen and they get fixed before they get launched as a product, right? So yeah, quality assurance and testing is a big thing, and verifying whether what's been implemented or designed from a solution perspective is actually what the software does, right? So I say to students, when they say their code's not working, there's kind of three things that can go wrong. It's their mental model of what they've written is wrong, the code itself is actually wrong, or something else, right? And being able to tell what those three things are is a very hard skill to do. And then a lot of programming and learning computing is about understanding when it fails and why is it failed and tracing it back and that sort of thing. So I think that's a big part of the industry that's not often understood as well.
That's really good to share, actually. And that leads me nicely, actually, onto what would you say are the types of characteristics best suited to doing computer science or following this type of career path?
So I think willingness to learn is a big one, and adaptability to learn as well. So computing. So if you imagine you graduate today in 2024 for computing, right, and you're going to go into that industry, and you're going to go into that industry for let's say 40 years minimum, right? The whole computing landscape in 40 years is going to be vastly different to what it is now. And you're not going to go for another degree, right? So you need to be able to adapt to new technology, and to be able to adapt to new technology, you need to learn how to learn, right? And that's a really important characteristic. And to be able to learn how to learn, you need to be like very inquisitive. You need to not play within the rules. You need to know, oh, if I do this, what happens? You need to have that kind of curious mind to say, oh, if I do this thing, what's the outcome, right? And a lot of students in some cases don't excel at computing because they don't see what happens if they do something weird and broken on a system and then say, oh, and that's how that works, right? So sometimes that is a missing characteristic.
Awesome. Thank you for that. I think that would be very helpful, and people maybe think, oh, am I like this or not? And then decide, whether this is going to be a good route for them, because this is what it's all about. Fab. So obviously you work at Bournemouth University, you've done your PhD, and I am keen to understand how you firstly actually researched to join them and decide to study there. But then also we can go into a little bit more detail around how you would recommend people to choose the right career and the right course for them.
Tricky. So I did my PhD and my undergrad course at Dundee, which is where I grew up essentially. Now I did my undergrad degree at Dundee in Scotland because I was a Scottish national, and that means I got my education free essentially. So I chose to go to Dundee because I chose to go to Scotland. I chose to go to Dundee, I should say, because it was commutable from my parents' house. And I thought, well, the degrees, I'm not going to pay for the degree. It doesn't make sense to get into any more debt just to move somewhere else. And because Dundee was quite well ranked for computing as well, so it made sense to choose Dundee as an option. And then my PhD, as I mentioned, it was funded. So again, that's kind of why I went with Dundee. But Dundee was heavily known for an area of research called accessibility, so developing technology to help people with disabilities. And the researcher that I did my work with, my PhD supervisor, that was what his background was in. So he moved from Canada to Scotland to Dundee to do that research there. So I kind of thought, well, if he's made the move to be over here, the research culture must be good enough for him to move over. So that kind of said, oh, maybe it makes sense to do the PhD here. And yeah, why did I move down to Bournemouth for work? I kind of liked their vision of what they were trying to do with their undergraduate courses. So they're very applied courses, and there's a lot of links with industry. And I think that's sometimes missing in a lot of university degree programs. They're very isolated, very siloed. And yeah, I wanted to live near a beach. That was the other reason.
I mean, that makes total sense. I don't blame you as an avid surfer. But also, I would say that, I mean, I've even seen it coming, I see a lot of Bournemouth graduates come through who I speak with, for example, who have done a year in industry and things like that. And I think there is a lot more applicable application from a lot of the degrees that they do versus some other universities, which is a big plus. So I guess that leads me nicely on to, how would you recommend people to choose the right course for them? Like, there are obviously lots of wonderful courses out there for computer science at undergrad, master's level, etc. But ultimately, how do they choose where to go based on other than just like university rankings, let's say?
Yeah, so we can touch on university rankings first, right? So what people don't often realize that university rankings are not purely based on the teaching reputation of that university. It's not solely that is part of it, but it's not solely based on that. So every couple of years, universities go through one process called the TEF, which is the Teaching Excellence Framework in the UK, where they all get ranked on certain teaching characteristics. Some things are ranked such as on student staff ratio, so the amount of staff you have in a department versus students. And it can't be zero. It can't be like 1-to-1 because that wouldn't make sense either. And it can't be like 1-to-250, right? It needs to be somewhere kind of in the middle, right? So that's one metric. And then the other metric that they're based on is this thing called the REF, which is the Research Excellence Framework. And universities from the government get a certain pot of money based on how excellent their research is. And the universities that get more money are the ones that place higher in this ranking, which for me is counterintuitive, right? So the universities who are doing the best research, who are already bringing in the most research money, get more money to increase their research ability, where if it was the other way around, that would make more sense. So you're going to always find the most prestigious universities are up the top end because they have the most money to, do things. So, for instance, facility spend, the amount of money that universities put into facilities, makes their ranking higher, which is why a lot of universities will build new buildings and all that kind of stuff, right? So the rankings don't really mean that the place is good at teaching. It's
a bit of a vicious cycle because, people who go to Oxbridge have normally come from private educated background, and then therefore they'll get trustees who will then put money back into the universities.
Exactly.
Because ultimately they can make charitable donations and then get their name, like get buildings named after them, etc.
Yeah, no, exactly. So I would say that some of the rankings, you can definitely look at them, and just be aware that they're not purely based on the teaching. So make sure you're looking at the teaching metrics within them. So if you compare like the top ranked school for something and then the 10th ranked school for something, and you look at the individual characteristics, you'll see that the only major difference might be the amount of research money they're bringing in, or the amount of research that they have, or whatever it happens to be. So I would say that's the first thing, that rankings are not everything. I would say the other thing is think about actually where you want to live realistically for 4 years, and what characteristics do you need to have a successful, I don't know, like mental well-being during that time. So a lot of students across our university, across many universities, are really finding mental health difficult. And I find that, going to university and moving away from your family is a tricky thing anyway. If you went to a particular place because you thought it was the best ranked university, but you didn't want to live there, then that's not going to be the best experience. So I'd say those two things first, right? Don't think about rankings. Think about where you actually want to spend 4 years of your life, and what else is going to help you be that person you want to be. And then I would think about more strategic. It makes sense to be at a university that's close to the industries you want to work in, right? So if you want to work in the financial sector, for instance, in London, then it makes sense to be at a university that's pretty close to that financial sector because it's likely they're going to have good links with those financial sectors, right? For instance, Glasgow University has a lot of good connections to JP Morgan because they've got a base up there, and Bournemouth has good connections to JP Morgan because there's a base down here. So sometimes you need to look at what big company is based around where I want to study, and then I would say go to as many open days as you can, and actually try and talk to the actual staff, because again, your experience is going to be influenced by those staff, right? Now those staff might leave by the time you go into your course. That happens, right? People in academia move around a lot, but you'll get a sense of what the culture is like at the institution and how well they're going to support you through those kind of open day events. So get a feel for what it's like to be a student really there. So walk around the campus, see how you feel, because that's going to be where you're going to spend a lot of your time. And then at that point, then I would start looking at the smaller things that's actually going to get taught. Because at the end of the day, what you're going to get taught on different degree programs. So if you study computing at Bournemouth versus computing at Dundee, let's say, probably going to come up with very similar skills, right? But it's the other stuff that fits around those skills that are important. So when you're at the open days, ask how do you involve industry in your teaching, for instance, or what would you say your student culture is like? How well do the student bodies interact across programs, because that's quite important. So yeah, things like that is what I would actually use to inform my decision if I was doing it again.
I think that's a really nice holistic view. Definitely mental health and like the other external factors that aren't just purely academic is incredibly important. I went to the University of Surrey, and I'd come from living in Brighton and being brought up in Brighton, which is a lot more of a vibrant city than Surrey. And I found Surrey, if I'm being really totally transparent, moving to Guildford was a little bit boring for me, which I think it was a bit of a culture shock for me actually, which was interesting. But definitely have a look at where you're going to be. That's brilliant advice. How will AI affect your profession or industry?
When you ask that question, do you mean my profession in terms of academia, or do you mean computing science in general? Because I think they're different answers.
There are definitely different answers. So let's go firstly with computer science in general.
So I would say that the public perception is that AI is this new thing that's just like appeared out of nowhere, right? Like magic, right? And I think actually AI has been increasingly important in computing for, I don't know, let's say the past 10, 15 years, right? So I don't think it has as much impact in computing as it might do in other fields where it's less transferable, or it has been less transferable in the past. I think it has influenced actual how we write software. So, for instance, GitHub, who are owned by Microsoft, took Microsoft's AI engine and embedded it into the development process. So you can essentially get GitHub, which for people who don't know, used to essentially be just a place where you could store code repositories. So essentially your code files. So a lot of open source projects, and for those of you who don't know what open source is, essentially wherein software is made open and anybody can contribute to it. So if something's open source, I as an individual developer can choose to be part of that project, write a bit of code and support that project in that way. And a lot of computing, a lot of what we use on a daily basis is open source, and it's maintained by random people all over the globe, right? So like the whole world is based on people just doing it off their own back for free, essentially. So that's what GitHub used to be mainly focused on. Now they've kind of shifted to more supporting developers, and they've embedded a lot of AI support into that. So I think what it will probably mean is that people spend less time actually developing code, and that's why those kind of interpersonal skills that I talked about earlier are even going to be more important, because if you're less valuable just because you can produce good code, what does it mean to be a computer science professional? So that would be how it would affect that. But I think, again, it's been affecting that for a long time, right? So I don't think it's going to change that much very soon, at least.
No. And just on the AI coding,
yeah,
how accurate is it?
So fairly. Again, you need to know. So if you took a random person off the street who had no computing experience and you asked them to use AI to build a website, they're not going to build the website, right? It's not going to make sense, or it's not going to be what you wanted it to be, right? If you took somebody who has a working knowledge of computing and give them an AI tool and get them to make a website, they'll probably make a working website, right? If you give somebody who has a lot of background in computing an AI tool to help them build a website, then they're going to be able to build a website that previously might have taken them a week or two in like an afternoon, right? So it's pretty accurate is the thing, but you need to know when it's not accurate. And I think that's actually the bigger challenge. So it's by knowing, oh, that's not quite what I want, and saying, oh, I want this. Or for instance, the other day I asked it to try and reverse engineer some student project that they did for me because I couldn't get access to the files, and I'm going to use that same thing for research with the students' permission now. But I asked it to just recreate this interface, but I needed to know what I was asking for, right? So I asked it to make me an HTML file and a CSS file, and by knowing even that those two files were separate things, then I got it to do it. If I didn't, it would have just made this messy kind of thing that kind of would have worked, but wouldn't have been very useful. So, yeah.
Interesting. And so how is AI going to affect your profession as a lecturer?
Well, I think it already has, right? So I think universities across the sector were very slow to react. So we think about ChatGPT came out a couple of years now, and when it first came out, the immediate scared decision by a lot of universities was to ban it, right? Ban it. We're not going to allow anyone to use it. And it kind of took a lot of people to be like, well, actually, we're not going to be able to prove that someone's used it or not. So actually banning it doesn't actually make a lot of sense. So we took a different approach, which I co-led in our department, that said, actually, what if we embraced it? What if the computing department, because we understand it, what if we embrace it and allow students to use it? How do we allow them to use it in effective ways? And then I've contributed to kind of Bournemouth University's AI think tank, which is kind of trying to lead the institutional response to that. So one way we did it was we allowed our unit leaders to choose whether they were not going to allow students to use it or they were going to fully allow students to use it. And those are the two different options. And when you're fully allowing someone to use it, you just give grading for different parts, right? So I think a lot of university degrees, in the past at least, have provided or not, or how they've marked or rewarded credit, let's say, for generating content, right? So like an essay, generating that essay is kind of what you get the marks for, or generating code is what you get the marks for. And that made sense when that was the hard bit, right? But actually, what you got the extra marks for, even in those times, were how well your content matched the brief, how well you explained or justified what you decided, or your argument, or whatever, right? So if the content's actually quite easy to produce, that justification is still quite hard. So if we shift the credit, or what we give the credit to, for that part that we're trying to assess anyway, then that's what I've been trying to push for. And actually, Bournemouth is going in that direction now, which is good. And I think a lot of universities are going in that direction as well, which is nice.
That's incredibly interesting, actually, hearing the use cases that you can apply within the academic world, because, I mean, obviously I work with tech companies, and there's lots of different ways that AI can be applied and help, and not necessarily hinder lots of different departments for lots of different things. So I guess it's all very much dependent on what you're doing. Brilliant. Okay, so let's go a little bit more into salaries for people when they graduate. So you obviously mentioned cybersecurity, data analytics, obviously software development, etc. Could you provide some insights into salaries when people graduate for these types of roles?
Well, I mean, I would say, to step back before that, right? You mentioned placement years. Often students that go on their placements, and that's really, they're doing their third year as a placement year, so they've only done 2 years of the degree. Their placement salaries are often like just as good, if not better, than the average salary in the UK. So their placement salaries can be like 30k or something, right? And that's not like the outlier. That's like the typical salary, right?
It's not bad.
So it's not bad, right? So yeah, I think the actual salary depends on what kind of company you go into, and what kind of workload you want, and what kind of thing you're supporting. So if you go and work on, JP Morgan, or even somewhere like Meta. So one of my friends who did his PhD at the same time as me, so we've got very similar skill sets, because we did both at the same degrees. He was working at Meta, and he was getting paid, 6 figures, right? For doing, and he wasn't a programmer. He was a user experience researcher, right? So he was leading a lot of Meta's internal research, mostly looking at policy, actually, and what their social media policy needed to be, and protecting vulnerable groups on Facebook. That's kind of what he was doing, and he was paid like 6 figures, right? So it does depend on what specific.
And that was
role.
after his PhD, just to clarify.
Yeah, but it doesn't necessarily need a PhD to go into that role. I think it's definitely easier if you have that kind of experience. And some of them do need that if you go to that kind of UX level. But there'll be developers who work at Google and Facebook who will be on 6 figures who don't have a PhD, right? They're just coming straight out of undergrad and going into those roles. I think it might take you a while to get to 6 figures, but not a long time. So yeah.
I agree. I think it's probably one of the most lucrative careers you can get. So probably. If you're money motivated, it is a winner. Honestly, I think, tech roles are by and far like most well-paid jobs in a lot of industries right now. So It is a fantastic career route. What 3 actionable steps would you recommend to those looking to get into a computer science related position?
So I think it depends. Are you saying before they've went to university, or before, or what point of their journey would you want the response to be? Because I think it's different depending on where you're at.
Definitely. I would say, let's say, for example, you have done, let's answer it on different facets. So first of all, I guess you're looking at doing an undergrad or converting and doing maybe that's probably a different conversation topic, but let's start with undergrad. So you're looking to do an undergrad. What resources would you recommend for people to like?
So I would say the first is to go and see if you actually enjoy programming, and you're not going to understand. You're not doing that to understand if you actually like physical programming, but it's, do you have an analytical and curious brain, right? So go and do, one of the best ones is Codecademy, has really good free courses on JavaScript and Python. So JavaScript's basically a lot of what runs web technologies. Python's used a lot in machine learning now. That's what basically builds the model for ChatGPT or AI engines, essentially. So go and play around with them and see how you feel of kind of expressing yourself in another language, which really is what programming is all about. And if you understand that, then see what kind of jobs you want to go into. And you might not know, right? But try and look up what those companies do, and what kind of roles might exist within those companies, right? So do you want to be helping on financial technology, right? Is that where you want to focus yourself? Do you want to build websites? Are you interested in AI, computer vision? Like what's your itch? What are you interested in terms of technology? Like what part of it? And then once you understand that, then I would start looking at courses and seeing what course pathway exists for you. Like what would actually get you to work in that specific industry you want to work in. I
love that. And I think that could probably be applied for anyone looking within that. So you've answered that as quite holistically, which is great. Fabulous. And what are your thoughts on, I'm going to ask you a bit of a one which is probably going to push the academic buttons here, but there are so many influencers out on the internet at the moment who talk about how they've just learnt to code online. How do you feel about that?
I think the first thing is it's really, really good, probably. I think what we don't have as much in computing as we should is like equal representation, right? So we have, in Bournemouth at least, we have a few women on our courses, but not as much as we like. And there's still a huge gap in terms of how many women are going into tech. And also people from different backgrounds going into tech as well. So disadvantaged backgrounds, for instance, is always something that's tricky as well. So I think the more the people understand it's there as an industry to go into. So if influencers can promote that, then I'm all for it, realistically. And actually having more people understanding how tech works in a kind of low level way. So it is good, right? So you've probably seen like a couple of months ago where somebody from TikTok was in the Senate talking to the US Senate on tech, right? And they just don't understand it, right? and that person who does understand it is getting questions that don't really make a lot of sense. So I think tech impacts so many different parts of the world and so many different industries. If you're in a meeting in a room and you understand just a little bit more than the average person, then that's going to be better for everybody, right? So I think that's another good thing about it, essentially.
Okay, that wasn't necessarily the answer I was expecting, but I quite liked
it. What was the answer you were expecting?
No, you're just standing for me like, no, you mustn't learn online, you must come to university to study.
I think it's tricky. I think university is only one pathway to get into a software development role. It's not the only pathway. It doesn't make sense for everybody, I don't actually think. As I said before, it's quite a challenging structure. It doesn't really fit into a lot of people from different backgrounds, right? So if you had, I don't know, let's say kids early on, right? The university degree is not really going to fit around that. Or if you have, so I've got a friend who works in hospitality at the moment, right? And he's really great at what he does. He's really good interpersonal skills, really understands business, and he wants to get into tech, right? Now, for him, I don't think university makes sense financially, or like that's going to be another 4 years for him to get into industry, right? But he already has a lot of the interpersonal skills, so he's already learned a lot of the business stuff. He really just needs that technical insight. And there's a lot of programs funded by the government actually to go through kind of code courses and connect you into those industries in those ways. So I think for him that makes a lot more sense, right?
Absolutely.
So
I was even speaking with someone, I think earlier this week, about how they work with platforms that do essentially provide those courses to, I guess, digitalize your skills. And it's actually a really nice platform for those, for example, who are maybe their mothers, maybe they're coming back from maternity leave and they actually have decided that they hated their job before and now they want to pivot and do something else. And those platforms enable them to then retrain and probably not a ridiculously high cost either,
No.
comparative to university fees these days, and do like digital apprenticeships, for example, and then they can often get placements at the end of them as well. So there are some examples like Multiverse, and some other like Coursera and some other boot camps as well out there. So.
Yeah, and a lot of them are essentially free for people to do, right? So there's I can't remember the government. I think it's the government upskill program, and a lot of they're kind of delivered through individual councils. So I know there's one running at the moment in Cornwall, and I know there's one in Hampshire, and there probably is other ones around the country. And it's around upskilling, and it doesn't cost you anything. You've got to commit to a certain amount of time and a certain amount of input, but other than that, it makes a lot of sense if you want to pivot. I
think it's a great initiative, to be honest. As I think I read a stat the other day about how millions of us are going to have to retrain by 2025, or 50% of the workforce. I think it was something as big as, in order to keep up with AI and so much, I guess, a velocity of technology changes. So.
I mean, I don't know. I mean, that's a stat that gets pulled out, right? And I think a lot of people think that AI is going to take all the jobs, and I don't think that's ever really going to be the case. Right. And I think a lot of times when new technology comes along, people freak out and say things are going to, change. Right. So, for instance, if you think about when the internet first launched, right, it created new jobs. Right. It didn't really actually kill off many jobs at all. Right. Again, if you don't have that adaptability to put your business online, for instance, that's tricky. Right. But I don't think it's really going to mean that so many people are going to have to retrain. Now, if you do retrain, are you going to have a competitive advantage in the workplace? Oh, absolutely, right? So actually, 50% of the population probably should retrain. I don't think they'll need to. I think that's the difference. And I don't think that's well communicated.
I think we've seen so many layoffs. We've seen hundreds of thousands of layoffs in the tech industry. And it is probably, in part because there is a little bit more AI, which does eliminate people's jobs a little bit. But at the same time, go for it.
Well, so I was at Google a couple of weeks ago, and I was chatting to somebody working at Google, and they gave me the kind of inside track on why all these layoffs were happening. And I hadn't really considered it before either. And again, this is kind of anecdotal, might not be the real case, but if you think about how much money these companies are putting into training these AI models, right? And we're talking millions, billions of money, right? Getting funneled into them, having the best trained model. And every single company is trying to build their own model. So Google's trying to build their own, OpenAI is trying to build their own, Meta's over here building their own, Microsoft's building their own, right? The real problem is currently they're not making any money from it, right? There's no return on investment. So they're cutting off all the departments they can so they can actually put as much money into AI. So it's not that AI is removing those jobs. It's these companies actually pivoting and saying, oh, we're going to, actually put the money that we do have over here, and they're not necessarily seeing a return yet. So I think once the companies will start making the financial money back, I think it will rise back up again. So I don't think those jobs are going away that they've cut off. I think they're just prioritizing this other thing in the moment, and that's my idea. Not my idea, my thoughts at least.
Yeah, I think that's a good insight, but you haven't discussed, you just talked about the big players in the industry, but there have been layoffs left, right, and centre with everyone below them as well. And I think that's obviously due to a lot of economic factors and political factors throughout the world at the moment, obviously, and how it's affected supply chains and everything, to be honest. So anyway, could have a whole different podcast on that. So anywho, so finally, Ben, what is the best piece of advice that you've ever received?
You call me off guard. The best piece of advice I've ever received
from a mentor or someone.
So I would actually probably say one of my colleagues I work with. It's probably maybe not the best piece of advice I've ever received, but let's say the most recent that stuck in my mind. The world is changed by the people who show up, right? So show up, be involved. Maybe that opportunity won't actually make sense, but the fact that you went and pushed your perspective a little bit, maybe that will change your perspective, and maybe it'll lead to different opportunities. So make sure you turn up and do different things, essentially.
I quite like that, actually. And what was the context of that conversation? How did that come up?
That was telling students why they should attend. No, but really that is. But I think we use it for that method as well, but also we do a lot of kind of code jams and hackathons where we set a challenge and we get them to work together. So we kind of tell the ones who've turned up, oh, really great you're here, you're going to have a great week. We use that metric, but I would also say, oh, tell your friends, that they should be here too, right? Because a lot of times we expect to get like 50 students to turn up to those events, and sometimes it's not as many as that, and it's kind of like, oh, they're missing out on the opportunities. And then they always see that the publicity of those events or the prizes people get, and they're like, oh, I wish I'd turned up. It's kind of like, well, yeah, you should have, right? So that's most of the context.
No, I think that makes total sense. And I think showing up in general and in life and pushing yourself out of your comfort zone is the only way that people grow and develop. And so that is definitely a key theme from some of the podcast, especially today. So thank you, Ben.
Good.
Well, it's been an absolute pleasure to have you, and you have definitely shared some really interesting insights, I have to say. I really enjoyed the conversation, so thank you so much for joining me today.
Thank you too. Yeah, good questions. Pushed me out my comfort zone as well.
Good, I'm glad to hear it. Great, thank you so much.
Thank you. Bye.
Thank you so much for listening to the What Do You Do podcast. Whether you're looking for a job or ready to find your latest inspired hire, head over to whatdoyoudo.com/jobs or click the link in the description. Don't forget to hit that subscribe button and share with anyone you think would love this episode.